1123, lowest common ancestor of deepest leaves. Given a rooted binary tree, return the lowest common ancestor of its deepest leaves. We call that the node of a binary tree is a leaf if and only if it has no children. The depth of the root of the tree is 0, and the depth of the node is d. The depth of each of its children is d plus 1, which I guess makes sense. The lowest common ancestor of a set S of nodes is the node A with the largest depth such that every node in S is in the subtree with root A. That was a mouthful. And okay, I mean, that's a standard definition of the lowest common ancestor. So what's the part? Given the root bind, return the lowest common ancestor. Okay, so given the two deepest leaves, return the lowest common ancestor. Got it. Okay, so the first thing I think when I see this problem, and this is maybe Leetcode specific a little bit, for interview, definitely just talk about all the possibilities and make sure you communicate with your interviewer for these things. It's always the most important thing. But yeah, why is there multiple things? Oh, they just, what are we returning? Actually, maybe I don't understand the input. Give me a second. Oh, I guess the input is just weird because we're given an actual tree, and it's just this is like the problem statement representation of that tree. So okay, so maybe I think they should have varied it up because this is just a little bit confusing to see. But in either case, okay, let's see. Deepest leaf is with 2 and 3. Lowest common ancestor is 1. The ancestor return is the tree node object, not an array. Okay, that makes sense because that representation of that node is this thing because it. Okay, okay. It's a little confusing to read, but in this case, I guess the node is 2. Okay. Yeah, as I was saying, the first thing because this is actually a known problem. The lowest common ancestor part is a known problem. It's just called the lowest common ancestor, and it even is known enough to have an acronym, which initialism. I always confuse initialism and acronym, but in either case, it's known as the LCA algorithm, and there's actually a really cool O of N algorithm for it, which require pre-processing and O of 1 queries and stuff like this. I mean, I guess this O of N if you don't have to pre-process, so that's fast. But and in this case, you only do it once, so you don't need pre-processing. But there are a lot of so if you're interested in that, there's a lot of good articles, and you should read it up. And it gets really and there's something that's really interesting to know. But in this case, N is only 1,000, so you could definitely just just find the deepest leaves. Can it have multiple? Because it's not just necessarily 2, right? So okay. That's actually maybe interesting. But in either case, yeah, I mean, I think when n is 1,000, you can even do n square stuff for sure. So we don't have to go that far, and it's kind of a known thing. So what I would do is what I was going to say. Actually, I think I misread or misassumed a little bit. Is that I thought that it's just the 2 deepest leaves, but I guess in theory, actually, there could be many things or many leaves. So I'm just drawing it right now. 4 and 5. Okay, I guess that makes sense. Then we have a 6. Then that. Let me try this real quick because I'm always confused about like tree problems are always a little tricky to do in life, I guess, in terms of input output. So I just want to make sure that the answer in this case should be 1, or with a prefix of 1. It's 1, 2, 3, 4, 5, 6, I guess. Right? How to do that? Oh, it's because I didn't actually return something. Just want to see what the expected answer is. I'm cheating a little bit, but I think I'm just on the non-contest you could cheat. Okay, so my assumption is right. So you have to go more. So there is a case where there are multiple deepest nodes, and then you just have to go up. Okay, yeah, and I think first we just do a depth first search to get those nodes, and then we just keep on going up in a binary search. Oh, sorry, not binary search, BFS, breadth first search, and then get the first node that almost like a union find actually. Now that I think about it, in a way. Yeah, I'll just keep going up from the way down. Yeah, okay. Let's get the set of leaves, the deepest leaves, and then let's do that. Um, hmm. I think right now I'm just trying to think whether we could do it in one recursive core. Um, and I think we can actually. Now that I think about it, maybe. Because basically, what does it mean? What does it mean if this node is the best, right? It means that your recursion on the left and the right are the same. So if that's the same, then you just return that node. Okay. Now I've deformulated it in a good way. Because basically what I'm thinking is this current node is the root of the deepest leaves if the recursion like we do a recursion on the left subtree and the right subtree, and they have the same depth, right? So okay, so I mean that's a way to define it, and in that case, if you do it that way in a naive implementation, then it would be n squared because you do the check after you already get the depth. But actually, no, you could just cache the result, so then it'll be O of n. Okay, let's do that then. Actually, that's kind of cool. I have to think through it a little bit. Oh, wow, I love downloads. Man, maybe today I'm just doing a lot of problems with a lot of haters. I feel like that's maybe okay. But let me say it's maybe okay after I submit the problem and correctly, because maybe I'll end up hating it because of a lot of edge cases. But okay, cool. Let's just say depth of a node x. What is the depth of node x? So okay, let's store each. Let's say it's none. Okay, let's just pre-calculate everything first. Okay, we'll just put it. I was just thinking about to be cute or with smart, quote unquote, and put it into in one function. But maybe I could just do two recursive functions, and they're both O of n, and that's fine. So the depth part should be easy then. If you don't need to, I say it's easy until it's not. But yeah. Okay, so what am I doing? Okay. That means it's depth is 1 or 0 maybe, but that means everything shifts by 1, so it doesn't really matter. Otherwise, and this is actually like inverse step actually in the naming, so but otherwise, oops, let me just cache this. So that depth is equal to 1 plus, I'll just say 1. Yeah, okay. And then if x dot left is not none, plus 1. Okay. We do the same for right. And also, I think the annoying thing about these prompts, and that's specific to maybe Leetcode, but just for contests in general, is that it's really hard to debug these things or visually, because if you have like an array or a matrix, you can just print it really quickly, and at least in Python. But in this case, it is not. So return would be nice. But now there's a debugger, I suppose. So maybe I could play around with that if it's necessary. I hope not. So anyway, this gets the deb, and now we can actually just traverse pretty straightforward. Oh, well, let's just do the deb of the root first. Actually, you could probably do it in a. I forget how you check in Python, like whether something is set, because Python is member set. I don't know, because you could. Okay, fine. And now we start from the root, right? So if I just call it. I know that I don't think we need the root anymore after this, but still. Okay. While true, let's say current if current.left is and we want to go to the side with the larger depth. Okay, if they're Leetcode, then we're done. So we could return current. If not, then current is equal to current.left, else current is equal to current.right. Okay. And then let's just say after that we continue on the loop. And then the other thing is then if they're both none, then that means this is already the deepest you go. I guess actually this could be part of the while loop, and then we just return it. Maybe that's fine. Maybe that's a little weird. De Morgan's law, if you're playing with that, because then now we could just return current, assuming you could type correctly. Okay, so else, then if left is none, because that means one of these has to be none. Left is none, then we just set it to current.right. Okay. It's like kind of crappy test cases that they give you, but it's a start. Uh-oh. Oh no, did I not set it? That was what I was worried a little bit, but I thought in here I would set it for all of them. Do I not do that? Look at my code for a second. I could certainly use the debugger, but when is there a case where I don't set it? That is weird. Now I remember though, it's has attribute. Something like that, right? X That, all right. Well, 28. I guess I added some code, but why would not this export entire tree? If then we go left, and then that sets it, right? We're in the first example, I guess. Okay, I just print it out. Oh, I guess this is actually the good time to use the debugger, perhaps. Oops. Let's try it out. All right. This is my first time. Let's see how that works. I don't know how to use this, so let me know. Okay. Oh, I don't need to step over. I can just keep going. 2, 4, 5. That's fair. It goes left, and then now 4. Then it goes 5. This is just a regular depth first search. The 3 and the 6, that also feels right. And the 6, okay. And then now there is a. I guess I should put one there. But the depth of search is okay. This is actually kind of cool. Not gonna lie. Because instead, I would have been just printing a lot of print statements. But okay, current is at the root. Why is that? Okay, I guess it already crashed, so I have to do it again. And friends, let's learn to use this debugger together, which is kind of cool. I'm not gonna lie, but okay. Dot left dot depth. Don't I set it? Like we set it for every node, right? Oh, I'm too used to different notations. Okay, I got it. This is actually x dot depth, not self dot depth. So very okay. Silliness. Okay, because I'm used to having it in its own class. Like in theory, I would put this in the tree node class because it doesn't really make sense here. But because I'm trying to shortcut it, that's why. Okay. Okay. Silliness. At least I hope that's the only one. Because now we actually set it. Okay, cool. Let's submit it. Oh, the debugger actually helped. What you know. Cool. Pretty fast. I mean, it's linear. I actually, yeah. And now that I've done it this way, I probably could have actually like just put it here, like in line 24. I'd be like, oh, if x dot left is equal to x dot right, we do some checking to see whether yeah, and then that would probably be good enough if it's the highest level or something like that. We could think about some logic, but definitely there are a couple ways to think about it. But yeah, let's see. Like, okay, let's barely fits everything on one screen. But yeah, but the idea again is just kind of having just really decomposing the question into the problem into just different components. And I think for me, it's just realizing what the lowest common ancestor means. And I think this is actually one thing that I like to point out sometimes from time to time. Sometimes mouthful, but it's that sometimes you can over prepare because I think as soon as I saw this, like it's similar to a lot of problems I've faced, but I definitely don't remember that this is a property of this. But it's kind of neat to me in a sense that like because you can convert this to well, if the left subtree is then the right subtree has the right same depth, depth, then and just having that insight already helps. But also, it's tough. I don't know how reproducible it is. In some good days, you just jump at the end. So on some bad days, you like sit there for half an hour. You're like, well, this was GG, right? But yeah. So the idea is, I mean, calculating the depth. I feel like it's maybe you could actually store this in like a lookup table or something like that. So the way I did it, I usually, at least in Leetcode, I've been storing stuff on the node itself, but you could put it on a lookup table and it's fine. And in this case, we just go down to kind of see where because the root is definitely the common ancestor, um, but we want to find the lowest one, right? And the lowest one is the first point in which the trees or like the deepest descendants are split up, right? And that happens when the left and the right trees have the same depth. So and this just goes down and just enumerate all the cases, or all four of them, I suppose. And then that's it. Like depending on whether left or right is, and so forth. Um, yeah, and I think it's easy to see that this should be O of n because we only hit each node once, and is O of n. Did I say time? O of n time because it hit each node. O of n times because it hits each node once, and it's O of n space because we store a depth variable on each node. So yeah, and in terms of I've seen way too many tree problems to not recommend you. There's too many double negatives there. But just yeah, this is definitely a problem that you could see. So definitely, yeah, tree problems are pretty straightforward. And I think this one doesn't have anything that tricky about it. Um, and even just the concept of LCAs in general, I feel like comes up a lot. So yeah, definitely think about that. Let's take a look at the hints. But yeah, I definitely recommend it. So yeah, do a post order traversal. Is that what I did? No, I did pre. No, I guess I did post order because I paused the depth afterwards. If both tree contain data, you can mark this node as answer so far. That's essentially what I did. If I no marked over you, okay. Yeah, I mean you could have done it like in the same place, but I opted not to because I forgot this thing. But it's not a big deal. I guess I could have just cached it, but cool. All right.